With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So let's see this question. In this question it is given a hydrocarbon X of the formula C6H12 does not react with bromine water, but it reacts with bromine in presence of light, forming compound Y. Compound Y on treatment with alcoholic KOH gives compound Z, which on ozonolysis gives T. Now T reduces Tollens reagent, which gives compounds W after acidification, and W gives iodoform test. And after acidification produces compound U, which when heated with P2O5 forms a cyclic anhydride V. Now compound V is. So first of all, the first line is important, that it is given that the hydrocarbon X of the formula C6H12 does not react with bromine water. So if it does not react with bromine water, means C6H12 must be a saturated hydrocarbon. It is a saturated hydrocarbon. So among saturated hydrocarbon, it means it is an alkane. Now in the second step, it is showing that it is reacting with bromine in presence of light. So if it is reacting with bromine in presence of light and there are 6 carbon atoms, so you can say that this may be the ring. You can have a 5-membered ring and here there will be CH3 attached. Now you know very well that if you treat bromine in presence of light, means if it is treated with Br2 in H mu, then if we consider this to be X, then what will happen, that selective bromination occurs, and at the tertiary position, the H will be eliminated, and that is bromine will be substituted here at the tertiary position because of the selective bromination in case of cyclic alkanes. Now at this position Br has been substituted. Now when you treat this, so this was the first statement, that is this will be the Y compound, right? This is Y compound. Now when you treat this Y compound, actually when you treat this Y compound with alcoholic KOH, right? We know alcoholic KOH is a reagent which is used to perform elimination reaction. So in elimination reaction, what will happen? Alkene will be formed. Now here you have two possibilities of alkene. One possibility is that if this Br and the H from this position, if it leaves and give you this type of formation, this is one possibility. And the other possibility can be like this also, that you have double bond here you have CH2 and Br and H from this position, this H and this Br leaves. Now among these two alkenes, we all know that this is the major product and this is the minor product. Why the first one is major product? Yes, this is major product because of the more hyperconjugation. We know very well that here more hyperconjugation occurs, more hyperconjugation is there, so it becomes stable, right? Because you can see how many hydrogen here. Here you have 2 hydrogens, then here you have 3 hydrogens, and then here you have 2 alpha hydrogens. So in total, if you consider how many alpha hydrogens are present, then that will, because of the more hyperconjugation, this product becomes major product, and this will be minor product because here you will have less number of alpha hydrogen. Here 2 and here you will have just 2. So 2 plus 2 is 4 only, right? So that's why this first alkene, it becomes more, you can say it becomes more major. So this is the product. So what you will say, the major product which will be formed, that is going to be Z. So Z is the major product. So this is Z. This one is Z. Now when you react this Z, actually, when you react this Z, when you react this CH3, this ZCH3 with what was the reagent? With ozonolysis. Now when you ozonolysis is done in presence of Zn, this is reductive ozonolysis, and what you get the formation of products like this. You have here double bond O and here you have CH3. So this is the product which you get, right? So this is called reductive ozonolysis, and you have double bond O here. So this is the product which you get after reductive ozonolysis, and which is this product? I guess it is T product, right? After Z you have T product, and when T is treated with Tollens reagent, it gives compound W. So let's see, this is the T product. Now when T is treated with Tollens reagent, if you treat this with Tollens reagent, what will happen? When you treat this compound with Tollens reagent, what is going to happen, you know? this CHO group, there is a aldehyde group like this here. So this CHO group will now get oxidized to acids in presence of Tollens reagent. So what will be the compound? The compound will be like this. You have C double bond O H. This is compound W. It will get oxidized in presence of Tollens reagent. It will get oxidized to acid. So this is compound W after acidification. So when acidification is done, this is compound W. Now, when this compound W is giving iodoform test, it gets converted into compound U, which when heated with P2O5 gives V. So first of all, this W is treated with what? It is treated with I2NaOH. Iodoform test is done. I2NaOH is the reagent. So when iodoform reaction is done, what happens in case of iodoform reaction? It must have a keto methyl group. So yes, you can see there is a methyl group adjacent to the keto position. So it is going to give you iodoform test. And in this case, what will happen? The product will be like this. You have C here in iodoform. What happens that this double bond O here, it gets converted into double bond O. Here also there will be an acid, and here also you will have an acid, double bond OH, right? So in presence of I2NaOH also you get the acidic salts here. So here also you will have double bond OH, and here also double bond OH was already present. So this is the product which you get after, and along with it you have CHI3 as the product, right? So what you will say that the compound U, after acidification you get compound U. So which is U compound? This is compound U. Now this is the compound which is formed after iodoform reaction, and this was CHI3, which is the organic compound iodoform. Now when U is heated with P2O5, it forms a cyclic anhydride. We know very well that if you heat this with P2O5, what will happen? Water will be released, and finally you will get a cyclic compound, cyclic anhydride here, and that cyclic anhydride structure will be, you will have 6 carbon over there, right? 1 2 3 4 5 6. So in total you are going to have how many carbons? 1 2 3 4 5 carbon, and there will be one oxygen. So let's draw the structure of the anhydride. So it will be like this. You have oxygen here, then you have the product like this, right? 1 2 3 4, right? This is, you should have 5 carbon. So it is like this here and now here. So this is the structure. Here you will have double bond O, and here you will have double bond O, right? You can see very well that at this position there is double bond O, and at this joining position there will be one double bond, and from here you are going to have this connection with this oxygen. So this is the way how anhydride will be formed, and this is the cyclic anhydride. This is the cyclic anhydride. Now very important part is that this cyclic anhydride is what? V. This was U, this is V. Now what was asked in the question? You were asked that compound 5 is. So what you are going to say? Compound 5 is, this B option is correct, right? So this is compound 5. So you will write here that option B is correct, right? I hope you have understood. Thank you very much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.